Hello, hello my dear friends, is the video and audio is clear? The one who is in the live, just say me whether the video and audio is clear. Is the, yes, right. Done. If it is clear, then we'll start the lecture. Hi everyone, hi. Right. Now, the video and the audio is clear, right? Right. Okay. Fine. My dear friends, you know right now, if you know the answer for the question, just try to solve it less than one minute or less than 2 minutes. Okay, don't take much time for the single question. If you know the answer, try to say me. If not, give me the question mark. I am ready to explain. Okay, don't be in hurry to give the answer. Just cross check the each and every options. Okay, right now we'll go with the first question. Now see the first question. I hope the question is clear. Let me increase the size of the question. Right. Now. Hi. Good evening everyone. Good evening everyone. Good evening to everyone. Good evening. Now. Right. What is the answer for the first one? In the following reaction, ZNO is representative acting as an ZNO is acting as an. Here the ZNO is acting as an. Good evening everyone. Good evening. ZNO is acting as an. What is the answer? What is the answer for this question? Answer is 2. Yes. Good evening. Now seniors, we will conduct the class at 9:40 like that. 9:40 or 9:45. Seniors, I will start the class at 9:45. Okay. Now, thank you, my dear Captain America, everyone. Someone is saying the answer is 2. Now here in the following reaction, ZNO representatively acting as an. Answer is 2. Good everyone, good. See, here Na2O, right? Now this is a Na2O. Now this Na2O is a basic, right? Now if this Na2O is basic here, then the ZNO is acting as a which one? Acid, right? Now when it comes to the CO2 is the which one? Acid. If the CO2 is acting as the acid here, then the ZNO is the base, right? In the following reaction, ZNO is representatively acting as first one acid, and in the second case it is base, right? Is it clear for everyone? Now in the following reaction, ZNO is representatively acting as an. Here Na2O is the base because here the Na2O sodium oxidation number is +1. Now in the CO2 carbon oxidation number is a +4. We know, right? We know higher the oxidation number on the atom. Now higher is the acidic strength. Clear? Done. The answer is 2. Now we'll move to the next question. Now I hope it is somewhat. Let me increase the size. Right. What is asking? Which of the compound contains highest mass percentage of nitrogen? Highest mass percentage of the nitrogen. Which of the following compound contains highest mass percentage of the nitrogen? Highest mass percentage of the nitrogen. Now say me the answer. Highest mass percentage of the nitrogen. What is the answer? Answer is 3. Answer is 3. Sure. Answer is 3. Now, here in the ammonia, how to calculate the percentage, mass percentage? Mass percentage will be calculated mass of atom by total mass of compound into 100, right? Now, in the first option, second, third and the fourth, in the first option, nitrogen atomic mass is 14, and in the nitrogen it is 7, and it will give you the 100. Approx you will get it as a 82%. Now in the NO2, 14 by, now 30, 16 plus 16, 32, 32 plus 14, 6, and it is 46, right? 46 into 100. Now in the hydrazine, in the case of hydrazine, 24 by 28 into 100, if you do, approx you will get it as 85%. In the option 3 it is correct. In the option 3 it will get yes. In the hydrazine case, 24 by 28 into 100. This is 24 plus 4, 28. Yes, good, everyone good. Now next question. Which of the following is asking, which one is not an limiting reagent? He is asking which one of the following is not an limiting reagent? What is the answer? Which one of the following is not an limiting reagent? I mean, which one will not follows the limiting reagent concept? What is the answer? Which one is not a limiting reagent question? Okay, I will give the option 1, 2, 3, 4. Someone is all or limiting reagent question. He is asking which one is not a limiting reagent question. He is asking which one is not a limiting reagent question. He is asking not is asking not. Which one is not a limiting reagent question? Actually, these two are the limiting reagent question. This one is a combustion reaction, right? This is combustion reaction. Now, among the normal reactions, and this one is a combustion reaction. This combustion reaction, no, limiting reagent. Okay, we'll see. One mass not given. Yes, here 1 mole of CH4 required 2 moles of oxygen. Now, actually, the first one will not comes under the limiting reagent because this one is a combustion reaction. This is combustion reaction question. This is combustion reaction question. Right? Now, next one. Now, what is the answer? The ionization energy of hydrogen atom in its ground state. The ionization energy of hydrogen atom in its ground state. The hydrogen atom one. Now, normally, if the electron, if it is present in n is equal to 1, now the energy formula is minus 13.6 into z square by n square electron volt. Now, what is the meaning of the ionization energy? Ionization energy is equal to what? Minus of energy, right? Minus of energy means this minus of minus will become plus. So the answer is A. Now with the same data, I will ask you one question. What is the ionization energy? What is the, with the same question, now I want to ask you one. Now, what is the ionization energy of an Be plus 3 ion, Be plus 3 ion in fifth excited state? Fifth excited state. What is the answer? What is the ionization energy of an Be plus 3 ion in fifth excited state? In fifth excited state. In fifth excited state. Good evening, good evening. Good evening to everyone. Now the same data you use for this one and send me the answer. What is the ionization energy of an beryllium plus 3 ion in fifth excited state? In fifth excited state. Same formula na, ionization energy is equal to plus 13.6 into z square by n square electron volt. Now plus 13.6 into z square of which one? Beryllium, right? Beryllium atomic number is 4. So 4 square will give you 4 into 4. It will give you the 16. 16 by fifth excited state. Fifth excited state means this is n is equal to 1 ground state, n is equal to 2 first excited state, n is equal to 3 second excited state, n is equal to 4 third excited state, n is equal to 5 fourth excited state, n is equal to 6 1 2 3 4 5. N is equal to 6 is the sixth excited state. Clear? Now sixth excited state means 6 into 6, that is 36. Clear? Now 16 by 36. 16 by 36. How much you will get? 16 by 36 into 13.6. If you do, you will get the answer 8.6. How much you are getting? 8.7. 8.7. This much, here it will be 8, here it will be 1 9, 8. Here it will be 4, here it will be 9. How much you will get? Approx. Approx you are getting 6.04, right? 6.04 you are getting. 4 into 4 it is 16 and it is 6. 6 into 6 it is 36. 16 by 36 plus 13.6. 6.04 you are getting. Not 8.7. 8.7. Fifth excited state means n is equal to 6. N is equal to 6 plus 13.6 into beryllium it is 4, right? 4 into 4 it is 16. 16 by 6th excited state means fifth excited state is nothing but n is equal to 6. N is equal to 6 means that is 6 into 6 it is 36. Approximately you are getting 6.04, not 8.7. Okay, is it clear? Is it clear to everyone? Or still you are having any confusion? 6.04 you will get. Yes, yes. Yes, yes. Okay, fine. Done. Done. Now, next question. Now, what is the answer for this question? What is asking? Which series of the line, which series of hydrogen spectrum lies in visible region? Which series of hydrogen spectrum lies in visible region? Good, 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 good. No, fifth excited state means you have to take it as 6. Answer is 2. Good, 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 good. Now, visible region will be Balmer series. Now, same based on this concept, I want to ask you one question. Now, calculate the wavelength in nanometer. Calculate the wavelength in nanometer. Calculate the wavelength in nanometer of hydrogen atom coming from infinity level to the UV region. Oh, what is the wavelength? UV region in hydrogen spectrum. Now say me the answer. Calculate the wavelength in nanometer of hydrogen atom coming from infinity level to the UV region in hydrogen spectrum. What is the wavelength? What is the wavelength? What is the wavelength? I'm asking in nanometer. I'm asking in nanometer. I'm not asking in lambda. I'm asking in nanometer. I'm asking in nanometer. Joshita. I'm asking in nanometer. I'm not asking in angstroms. My dear friends, you have to be very careful. The answer is 91.2. See, if the lambda they are asking in angstroms, then you have to use the formula 912 angstroms by z square into 1 by n1 square minus 1 by n2 square. Clear? Now this is about the lambda. Now if suppose they are asking in the nanometer, then if they are asking in the nanometer, then that is a nanometer is 1.2 angstrom by z square into 1 by n1 square minus 1 by n2 square. Clear? Now the hydrogen atom Z is 1. Hydrogen atom Z is 1. Now the electron is coming from the infinity level, means higher energy level, it is 0. 1 by infinity it is a 0. Then 1 by, when it is coming to the UV region means that electron is coming to the, from where to where? From the higher energy level to the n is equal to 1. Higher energy level to the n is equal to 1. That series we call it as a Lyman series. In the Lyman series, electron will be falls under the UV region. Now, if the electron, if it is coming and falls under the n is equal to 2, and that we call it as a Balmer series, and that we call it as a which one? Visible region. So now the electron is coming to the 1, so this entirely it will become 1. Now the lambda, if it is in the nanometer, that is 91.2. Is it clear? 91.2. You have to be very careful. That's the reason I mentioned very clearly in the unit in the nanometer. You have to be very careful with the unit. Right. Next. Now, the valency electron of an element with atomic number 35. Valency the valency of an element with atomic number 35 is. The valency of an element with atomic number 35 is. Valency of an element with atomic number 35 is. Option 1, 2, 3, 4. Valency of an element with atomic number 35 is. Valency of an element with atomic number 35 is. Good Suraj, good Chandana. Good everyone, good. Atomic number 35. Atomic number 35. But you are getting somewhat. Once again you cross check everyone. Valency electrons is asking. Valency electron, the valency of an element with atomic number 35. Valency of an element indirectly is asking the valency electrons. Bromine valency is how much? Bromine valency electrons ana? Bromine valency electrons. Are? Why you are getting confusion? It is 35 is the bromine, okay. How many valency it will be there? Answer is 7. Then why you are saying it as... See, already I explained you very clearly. Helium, neon, argon, krypton, xenon, radon. Now this is 2, 10, 18. This is 36, its valency electrons are 8. Then atomic number 35 here. 35 valency electrons are 7, right? Then how come it will be 1? Answer is 7. Bromine contains 7 valency electrons. Bromine contains 7 valency electrons, not the 4. Already I explained very clearly. Again and again you are doing the same mistake. See, this is boron family. Next, carbon family. Next, nitrogen family. Next, oxygen family. Next, halogen fluorine family. And this is a which one? Noble gases. Noble gases will have the 8 valency electrons. Halogens will have the 7 valency electrons. Now oxygen family will have the 6 valency electrons. Nitrogen family will have the 5 valency electrons. Carbon family will have the 4 valency. Boron family will have the 3 valency. You have to be very careful, my dear friends. Don't pick the answer. Try to cross check. Here already the 1764 they have given. The answer is 7. Clear? I hope it is clear. Now, based on this one, I will ask you one question. Now, atomic number 57, atomic number 57 comes under which group and which block? Comes under which group and which block? Atomic number 57 comes under which group and which block? Atomic number 57 comes under which group and which block? Atomic number 57 comes under which group and which block? My dear friends, you have to be very careful. While you are giving the answer, you have to be very careful. My dear friends, the NTA will catch your weakness. Group number you are saying the correct, but block is wrong. My dear friends, atomic number 57 will comes under third B group, but it belongs to D block element. It belongs to D block element, not F block element. Not F block. You have to be very careful with this one. This is very important. Very important. Atomic number 57 will comes under the D block, not the F block. Only already I explained very clearly that lanthanide, this lanthanide atomic number is 57. This lanthanide atomic number is 57. It comes under the which one? D block element. It comes under the D block element. But lanthanide elements from the cerium, it is 58 to 71. 58 to 71. It will comes under the which one? It will comes under the F block elements. It will comes under the F block elements. Cerium to lutetium. These 58 to 71 only will comes under the F block element. But lanthanide element will not comes under the which one? Lanthanide element will not comes under the F block element. You have to be very careful with this one. This 57 element atomic number will be xenon 6s2, xenon 6s2 5d1, xenon 6s2 5d1. So you can see this xenon atomic number is 54, 55 and 56 and 57. See, last element is entered into the D block element, right? So that's the reason lanthanide element will comes under the D block element. You have to be very careful with this one. And repeatedly I was saying you, and repeatedly you are doing the same mistake. So the answer is, it is third B group and D block element. Third B group and the D block element. Next one. Which of the following element belongs to the P block? Which of the following element belongs to the P block? Which of the following element will be belongs to the P block? Answer is Al. Good, 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 good. Good, good. Now, right. Answer is Al. Right. No. Okay, good, 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 good. Now I will write the one element name that you have to say me in which period, which block it will belongs. Now this AT will belongs to which block? It belongs to which block? This AT will belongs to which block? This AT will belongs to which block? This AT will be belongs to which block? Good, 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 good. Astatite, it will belongs to the P block. It will belongs to the P block. Right. Clear? It will belongs to the P block. Yes, if you want the atomic number, write helium, neon, argon, krypton, xenon, radon, Og, right? Now here it is a fluorine, chlorine, bromine, iodine, 80. Now this is a 86. Now this atomic number will be the 85. Atomic number, it is a 85, and it will belongs to the P block. 80 will belongs to the P block. P block, which period? 7th group, 7th A group. 7th Roman number, 7th A group or 17th group, and the period number will be 1, 2, 3, 4, 5, 6. 6th period. Next. Is asking which of the following hybridization is sp3? Which of the following hybridization is sp3? Which of the following hybridization is sp3? 1, 2, 3, 4. Which of the following hybridization is sp3? Answer CH4. Answer is A. Good, 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 good. CH4 hybridization is sp3. Then what is the hybridization of BF3? Now what is the hybridization of BF3? And what is the hybridization of CO2? And what is the hybridization of BCl2? Good everyone, good, good, good. My question is, what is the hybridization of BF3? What is the hybridization of CO2? What is the hybridization of BCl2? What is the hybridization of BF3? What is the hybridization of CO2? What is the hybridization of BCl2? Good everyone, good, good, good. The one who has given the answer, good, good everyone. But my question is, what is the hybridization of BF3? What is the hybridization of CO2? What is the hybridization of BCl2? CO2 Sp. Now only I will say, for the NEET students, atomic structure, classification of periodic table, chemical bonding, mole concept. So 4 chapters are there. 4 are equally having weightage. 4 are having equally weightage. Because you are having 45 questions, right? Now 45 by 4. Divide the 45 by 4. Equal weightage you will get. Right. BF3 is a sp2. BF3 is a sp2. Now CO2 is sp. BCl2 is also sp. BCl2 is also sp. Right. Now next question I want to stress it from you is, here I will write the some molecules. CH3 plus, right? Next, this molecules only I will write better. CH4 comma BF3 comma CO2, right? Now here, what is the percentage P character in CH4? What is the percentage P character in BF3? What is the percentage P character in CO2? Now say me the answer. 1, 2, 3. In the 1, 2, 3, what is the percentage P character? For the main students also same. For the named students also same. For the main students also same weightage. You are having the 25 questions, right? 25 by 4. For the main students, 25 questions, 25 by 4. At least for the one chapter, you will have the one extra question. Now, what is the percentage P character? For the first one, for the second one, and for the third one. What are the percentage P characters? Which one 20%? 75. For which one? Which one 75? 25, 33.3, 50. 25. Now, first one is sp3, right? First one is sp3. sp3 means percentage S character will be how much? 25. Percentage S character is 25 means percentage P character will be 75. So the first one we are having the percentage P character 75. Second one hybridization is sp2. If the percentage S character is how much? 33.3 means now the percentage P character will be 66.6, right? Approx 66.6, right? Now this one is a sp hybridization percentage S character is 50, then percentage P character is 50, then here the percentage P character is 50. So the answer is 75, 66.6 and the 50. 75, 66.6 and the 50. Yes, good everyone, good. Next one. Which of the following species is paramagnetic? Which of the following species is paramagnetic? Which of the following species is paramagnetic? One, two, three, four. Which of the following species is paramagnetic? My dear friends, see the options carefully and try to give me the answer. Don't be in a hurry to give the answers. See the options carefully and try to give the answer. He is asking paramagnetic, not the diamagnetic. Which one is a paramagnetic is asking. Which one is a paramagnetic is asking. No. Answer is not the one. My dear friends, once you cross check the each and every options and try me. Don't be in a hurry to give the answers. Don't be in a hurry to give the answers. Which of the following species is paramagnetic? The answer is 3. Good. Because only one thing you have to remember now. This is the 14 electrons. 14 electrons, it is a diamagnetic in nature. This is 14 electrons. Diamagnetic in nature. Right? O2, it is a 16 electrons. 16 electrons is paramagnetic in nature in the MOT. Right? Now, this is a H2O. H2O octet complete. Octet complete species are diamagnetic. Right? Now, octet complete species are the diamagnetic. This is now here, but in the H2O, according to the MOT of the H2O, sorry, O2, according to the MOT of the O2, O2 is paramagnetic. Already I explained you. Now, for the even number electron species with 10 electrons and 16 electron species are paramagnetic. Rest all are the dia. Clear? You have to be very careful with this one. Rest all are the dia. Now these two are the para. Now he is asking which of the following species is para. O2 is para. I hope it is clear. Now, based on this one, I will ask you one question so that whatever maybe the concepts you are having, whatever the misconceptions you are having, it will be clear for you. Right? Now, C2, next one B2, next one B2 plus, next B2 minus, next N2, next CO, next O2, next O2 minus 2, right? Now 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8. How many of the following species are diamagnetic in nature? How many of the following species are diamagnetic in nature? Diamagnetic. How many of the following species are diamagnetic in nature? How many of the following species are diamagnetic in nature? Four. What are those? Janakiram, may I know what are those species will comes under the diamagnetic? What are the species that it will comes under the diamagnetic? What are the species that will comes under the diamagnetic? What are the species that will comes under the diamagnetic? What are the species that will comes under the diamagnetic? 1568. 1568. Now, this is 12 electron species. This is 12 electron, right? 12 electron species will comes under the dia. Now, this is 10 electrons. Already I explained you 10 electron species will comes under the which one? Para. Next, B2 plus. B2 plus will comes under the 9 electrons. Boron is 5. 2 borons will be 10 and plus is loss of electron. Now this is 9 electron. 9 electron will be para. Now B2 minus means this is 11 electron species. 11 electron species also para. Right. Now this is N2. N2 is 14 electrons. 14 electrons is a dia. Right. CO is a 14 electrons. 14 electrons is dia. Right. O2 minus 2. This is 18 electrons. 18 electrons it is a dia. Now O2 is a 16 electrons. 16 electrons it is a para. Blindly believe that 10 electron species and a 16 electron species are, even though those are having the even number, but those are paramagnetic in nature. Paramagnetic. You have to be very careful with this. Okay, good, my dear friends, good. 1568. 1568 is the answer. Good, everyone, good. 1568. Only the 1568 is a which one? Is a diamagnetic in nature. Now, next question. Based on this concept only, the next question. C2 plus N2 plus O2 plus, okay, O2 plus, next He2 plus, okay, next H2 minus 2, comma, next B2 comma, next next He2. Now here this is a 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, right? 1 2 3 4 5 6 7, 1 2 3 4 5 6 7, right? Now sum of all the bond orders. What is the sum of all the bond order? What is the sum of the all the bond order? Bond order. Now sum of all the bond order. Now add all the bond orders and see me the answer. Add all the bond orders and see me the answer. Add all the bond orders and see me the answer. Add the all the bond orders and send me the answer. If you know the answer, say me. If not, give me the question mark. I am ready to explain. Answer is 8. Ajit Boxer is saying 8. Okay, now we'll see. Here already I explained you the one beautiful trick for that one. Here, which one? C2 plus. Carbon it will having the which one? Now already I explained you the one trick, right? What is that one trick? 1 electron 0.5, 2 electron 1, 3 electron 0.5, 4 electron how much? 0, right? 5 electron 0.5, 6 electron 1, 7 electron 0.5 and 8 electron 0, right? Next 9 electrons 0.5, 10 electron 1, 11 electron 1.5, 12 electrons how much? 2, 13 electron 2.5, 14 electrons 3. Now from the 14 to 20 decrease 0.5, right? 15 electrons 2.5, 16 electrons 2, 17 electrons 1.5, 18 electrons 1, 19 electrons 0.5, 20 electrons 0. Now cross check here in the first one, how many C2 plus carbon it is having the 12 because 6 plus 6 12 and one loss of electron, how many? 11. 11 electrons bond order is how much? 1.5. Now N2 plus 14 and the loss of electron is 13. 13 electrons bond order is 2.5. 2.5, right? Now O2 plus is nothing but 15 electron bond order is 2.5. 15 electron bond order is 2.5, right? He2 plus helium contain 4 electrons, right? He2 4 and the loss of 1 electron will be 3 electrons bond order is 0.5. Now He2 plus hydrogen contain 2 electrons and the gain of 2 electrons will give you 4 electron bond order is 0. He2 minus 2 will not be exist in the nature. Then Be plus 2, Be2, sorry, beryllium contain 4, beryllium 4 plus 4 it will give you 8 electron bond order is 0, this is 0, right? He2 4 electron bond order is 0. So here 2.5 plus 2.5, 5 plus 5 plus 2 the bond order is total sum of all the bond order is 8. Here 0 0 0 bond order 0 0 0. Here 2.5 plus 2.5 5 and plus 2, 5 plus 2 7, right? Sorry, 2.5 plus 2.5 it is 5, 5 plus 2 7, sorry, overall answer is 7. He2 plus bond order is 0, Be2 plus bond order is 0, He2 bond order is 0, so the overall answer is 7, not 8. My dear friends, overall bond order is 7, not 8. Ajit, somewhere you have did the wrong. No, once you cross check, the overall bond order is 7. Okay, is it clear? I hope it is clear for everyone. Or still you are having any confusion? I hope it is clear for everyone. I hope it is clear for everyone. Clear, right? Now we'll move to the next question. He's asking the aqueous solution, which salt will not contain the electronic configuration? Which salt will not contain 1s2, 2s2, 2p6, 3s2, 3p6? Which salt will not contain ions with electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6? What is the answer? What is the answer? What is the answer? Chesty is asking the salt, how the salt will be dissociated? This salt will be dissociated as a Na plus and F minus. This salt will be dissociated as Na plus and Cl minus. Right? Now this salt will be dissociated as K plus and Br minus. This salt will be dissociated as Cl plus 2, Ca plus 2 and I minus. Right? He is asking, what is asking, which of the salt will not contain ions with electronic configuration? This one. No, the answer is 1. Answer is 1. My dear friend, the answer is 1. See, Na electronic configuration is neon electronic configuration, right? 1s2, 2s2, 2p6. And fluorine electronic configuration, fluorine is 9 and it is gain of electron 1. Total it has reached to the neon. This electronic configuration is 1s2, 2s2, 2p6. But he is asking which of the following will not contain, ions will not contain this electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. But here the sodium may not contain, but chlorine will contain, right? Because 17, 17 and 1 electron gain, it has become 18. 18 electronic configuration is argon. This is argon electronic configuration only. 1s2, 2s2, 2p6, 3s2, 3p6. Right? Now you can see here the bromine ion may not have the this electronic configuration, but potassium it is having the this electronic configuration, right? Here the iodine may not having the which one? Argon electronic configuration, but Ca plus 2 is having the argon electronic configuration, right? But here the Na plus and the F minus both are not having this argon electronic configuration. So the answer is 1. Okay, I hope it is clear. I hope it is clear for everyone. NaF is not having the argon electronic configuration. NaF is not having the argon electronic configuration. Right, done. Next. The dipole moment of the molecule is 0. Dipole moment of the molecule is 0. Dipole moment of which molecule is 0? Dipole moment of which molecule is 0? Dipole moment of which molecule is 0? Joshita is saying the dipole moment of CCl4 is 0. Dipole moment of CCl4 is 0. Right. Now, here the NH3. Only one thing you have to remember, Nana. Just whenever the dipole moment questions, if they gave this trick what I was saying, 95% it will be accurate. 95% of the molecules it will give you the answer. 95% of the molecules. Only one thing. What? Central atom without lone pair of electron. Central atom without lone pair of electron. Central atom without lone pair of electron. Its dipole moment is 0. Hybridized molecule, central atom without lone pair of electron, its dipole moment is 0. How? Here you can see NH3, it is sp3 with one lone pair. sp3 with one lone pair, its dipole moment will be there. H2O is also sp3 with two lone pair, right? But here the CH3Cl3. Now the hybridized molecule should have the identical atoms attached to it. Central atom without lone pair of electron, its dipole moment is 0. But bonds should be same. Bonds should be same. I mean atoms which has attached, that bond should be same. Now here the CHCl3. Here the lone pair of electron may be 0 on the central atom, but bonds are different, right? Here the Cl, here the Cl, here the Cl, and here it is the hydrogen. So that's the reason its dipole moment is non-zero. But when it comes to the CCl4, bonds, all the bonds are identical. All the bonds are identical, as well as its hybridization is sp3 and 0 lone pair, and fourth one is a 0. Dipole moment is 0. Just one trick you remember. This trick I will write it here. Next one. Next one I will write you sum of the molecule. Now you have to say me the answer. CO2, H2O, CO2, H2O, NF3, SF4, SF6, next one CLF3, next one BF3, next CH4, next PCl5. Now, how many of the following molecules are having dipole moment? How many of the following molecules are having the dipole moment? Now, say me the answer. How many of the following molecules are having the dipole moment? How many of the following molecules are having the dipole moment? How many of the following molecules are having the dipole moment? 5. What are those? What are those molecules? Can anyone say me? What are those molecules? What are those molecules having the dipole moment? What are those molecules that are having the dipole moment? 5 is saying by the Ajit, and Akshara is saying 4. What are those molecules? 1578. Dipole moment, my dear friend, CO2 is a non-polar compound. It is a non-polar means it is a non-dipole. Its a dipole moment is 0. Dipole moment is 0 for the, because this is sp with 0 lone pair. This is sp with 0 lone pair. It is not the dipole. It is not the dipole. One is not the dipole compound. One is not the dipole compound. Second one is dipole. Which of the following is dipole? I am asking. Which of the following is dipole? Dipole compound is asking. Dipole means central atom with lone pair of electron. If it is present, that is a dipole. Central atom without having any lone pair of electron with identical atoms attached to it, those are which one? Those are non-dipole or non-polar compounds. This is dipole compound. This is dipole compound. Now this is dipole compound. This is non-dipole compound or non-polar compound. Now this is dipole compound. Now this is non-dipole compound or non-polar compound. Now this is non-polar and this is non-polar. Only 1, 2, 3, 4, 6. Only 4 are correct. Answer is 4. Answer is 4. So in that the dipole compounds are 2. This is having the lone pair of electron. Here it is having the lone pair of electron. Here we are having the one lone pair of electron. In the ClF3 we are having the two lone pair of electron, and the remaining all are absent. Lone pair of electrons are absent on the central atom. Oh no, only the answer is 2, 3, 4, 6. Only the 2, 3, 4, 6 is the answer. My dear friends, you have to be very careful. Now once again you cross check or once again try to revise your concepts once again. Okay, these misconceptions will lead you to give the wrong answer even though you know the concept. Even though you know the concept, this type of the misconception will lead you. Okay, you have to be very careful with this one, right? Now, next question. Now the group having isoelectronic species. The group having isoelectronic species. The group having isoelectronic species. Okay. Now, once again I will explain this dipole moment compound, dipole concept. Listen. With a fresh page I will explain. Now first one is CO. Second one is H2O. Okay. Third one is, what is the third compound? NF3. Third compound is NF3. Okay. Fourth compound is SF4. Fifth compound is SF6. Sixth compound is CH4. And the last one is a PCl5. Okay. Seventh one is a PCl5. Right. Now only the one statement you remember. That one statement is central atom with identical atoms attached without lone pair. Without lone pair is non-polar or non-dipole compound. Dipole moment is 0. Non-dipole or dipole moment is 0. Dipole moment is equal to 0. Right? Now, here first this CO2 hybridization is sp with 0 lone pair. sp with 0 lone pair, but bonds attached are identical. Bonds attached are identical. sp with 0 lone pair. It is dipole moment is 0, so it is not the dipole compound. But when it comes to the NF3 central atom with how many lone pair? Central atom with 3 lone pair, right? Central atom with 3 lone pair. Central atom with 3 bonds and 1 lone pair, and its hybridization is sp3 with one lone pair. sp3 with one lone pair, what I said, if identical atom, central atom, if it is having the lone pair of electron, if the central atom with identical atom attached without lone pair of electron is non-polar or non-dipolar, dipole moment is 0, but it is having the lone pair of electron, right? This is dipole. Now sf6, it is sp3 d2 with 0 lone pair. sp3 d2 with 0 lone pair, central atom, it is not having any lone pair of electron, it is which one? Non-dipole or non-polar. Now H2O, this is sp3 with 2 lone pair. sp3 with 2 lone pair, what is that? This is dipole compound. Now sf4, this is sp3 d with 1 lone pair. sp3d with 1 lone pair. sp3d with 1 lone pair, it is dipole compound. Next CH4, this is sp3. sp3 means what? sp3 with 0 lone pair, it is non-dipole or non-polar. Now PCl5, this is sp3 d with 0 lone pair on the central atom, it is non-dipole, right? Right. Next one, this is now the group having the isoelectronic species is, now the group having the isoelectronic species is, what is the answer? Group having isoelectronic species, answer is 2. Can anyone say me the answer? The group having the isoelectronic species is, group having the isoelectronic species, what is the answer? Group having the isoelectronic species. See the option carefully and try to give me the answer. Don't be in hurry to give the answer. The answer is 3. Good everyone. Answer is 3 because O2 minus, F minus, Na plus and Mg plus 2 all are having the 10 electrons and those are isoelectronics to each other. Yes, good. Option number 3, good. Next, the electron gain enthalpy in kilojoules of the fluorine, chlorine, bromine, iodine respectively are. They are asking negative. Now electron gain enthalpy of the fluorine, chlorine, bromine, iodine respectively are. The electron gain enthalpy of fluorine, chlorine, bromine and iodine respectively are. Fluorine, chlorine, bromine, iodine respectively are. What is the answer? Electron gain enthalpy of fluorine, chlorine, bromine, iodine respectively are. What is the answer? The electron gain enthalpy. Answer is B. Answer is B. Can anyone give me the answer? Can anyone say me the answer? Can anyone say me the answer? See, electron gain enthalpy for the halogen, fluorine, chlorine, bromine, iodine, chlorine greater than, fluorine greater than, bromine greater than, iodine, right? Then negative electron gain enthalpy is asking. Negative electron gain enthalpy. Now the highest is 349 and the least is minus 249, right? Now the highest is minus 349 kilojoules of energy will be for the which one? For the chlorine. Next minus 3.33 will be for the which one? Fluorine. Now bromine will be 325 and iodine will be minus 296. So the which option is asking? Fluorine, chlorine, bromine, iodine respectively, right? So fluorine is minus 333, okay. Chlorine minus 349, okay. Bromine minus 325 and iodine 296. So option number B is correct. Option number B is correct. Option number B is correct. Because the order is electron gain enthalpy for the halogens are chlorine greater than, fluorine greater than, bromine greater than, iodine. So the answer is minus 349, minus 333, minus 325 and the minus 296. So the answer is B. Answer is B. I hope it is clear. I hope it is clear for everyone. Right. Right. No. My dear friends, be fast. Now we are having the plenty of questions to do. What is the answer for this question? What is the answer for this question? The structure of PCl5 in solid state. The structure of PCl5 in solid state. The structure of PCl5 in solid state. Amma is asking in solid state, not in gaseous form. You have to be very careful with this the question. Don't be in hurry to give the answer. My dear friends, don't be in hurry to give the answer. PCl5 in solid state is asking. PCl5 in solid state. Amma is not asking the question in PCl5 in the gaseous phase. PCl5 in the gaseous phase, that is sp3d, so that is a trigonal bipyramidal. But in the PCl5 in the solid state, PCl5 in the solid state, it will be dissociate as a PCl4 plus and PCl6 minus. PCl4 plus and the PCl6 minus. So the PCl4 hybridization is sp3 and PCl6 hybridization is sp3d2. So answer number is 2. Tetrahedral and octahedral. Tetrahedral and octahedral. So here the PCl5 in the solid state, it will be dissociate as the PCl4 plus solid and PCl6 minus. But in the gaseous form, it is having the sp3d hybridization. But in the solid form, it is having the sp3 and sp3d2 hybridization. I hope it is clear. Right. I hope it is clear for everyone. Or still you are having any confusion? Still you are having any confusion? Is it clear? No. Next. The number of subshells associated with n is equal to 4. N is equal to 4 and n is equal to 3. Now show me the answer. Number of subshells associated with n is equal to 4, m equal to minus 2. What to separate them? This will be dissociate to the PCl4 plus and the PCl6 minus. Now the number of subshells associated with n is equal to 4 and m is equal to minus 2. The number of subshells what is the answer? The number of subshells. If the n is equal to 4, the possible L values are 0, n is equal to 1, L is equal to 2, L is equal to 3. Now here in the, if L is equal to 2 means that is D subshell, if L is equal to 3 means that is F subshell. Now D Orbitals are -2, -1, 0, +1, +2. For the F, it is -3, -2, -1, 0, +1, +2 and the +3. So the only we are having that is 3D, sorry 4D, and the 4F orbitals are allowed. So the number of subshells associated with the n is equal to 4 and m is equal to 2. The quantum numbers is the number of subshells are 2. Answer is 2. I hope it is clear. The answer is 2. Right. Next, the molarity. What is the molarity of 4.9 gram of H2SO4 in 500 ml of solution? What is the molarity? What is the molarity? What is the molarity of 4.9 gram of H2SO4 in 500 ml of solution? Five hundred ml of solution. What is the molarity of? Answer is 2. See, what is the molarity formula? Molarity is equal to number of moles by volume in liter, but here the volume they have given in the ml means, then you have to consider, and the weight of the solute they have given, then weight of the solute by molecular weight of the solute into 1000 by V in ml, right? Now weight they have given 4.9, molecular weight of H2SO4 is 98 into 1000 by 500. Now here it will 2, then after that 4.9 by 98 into 2, then it will go 4, and here it is a 6. 4.9 by 4.9 by 46. How much you will get? How much you will get in a 4.9 by 4.9 by 46? 0.1. Okay, answer B. Good, good everyone, good. Good. Next. Which of the following the central atom does not follow the octet rule? Does not follow the octet rule. Central atom does not follow the octet rule. Which of the following the central atom does not follow the octet rule? Which of the following does not follow the octet rule? Yes, yes, good, good, good. 0.1. Which of the following does not contain octet rule? What is the answer? Answer is 1. Answer is 1. Good everyone, good, good, good. Yes. Now you see PCl5 is having the extended octet. PCl5 is having the extended octet, right? Extended octet. CH4 octet followed. CO2 octet followed. CCl4 octet followed. Right, right. Good, good. Answer is PCl4. Now the percentage of the nitrogen in ammonia. The percentage of nitrogen in ammonia. Percentage of nitrogen in ammonia. Percentage of nitrogen in ammonia. Answer is A. Percentage of nitrogen in ammonia. Percentage of nitrogen in ammonia. Very easy question. Percentage of nitrogen in ammonia. 14 by 17 into 100. That's it. It is 82 percentage. It is 82 percentage. Yes, it is 82 percentage. Equivalent weight of KMnO4 in acidic medium. This is one nice question. Equivalent weight of KMnO4 in acidic medium. Yes, good. Equivalent weight of KMnO4 in acidic medium. Equivalent weight of KMnO4 in acidic medium. Answer is B. Equivalent weight of KMnO4 in acidic medium. What is the answer? Equivalent weight of KMnO4. Now, molecular weight of the KMnO4 is 158. Equivalent weight formula. Equivalent weight is equal to molecular weight by N factor. Right? In the acidic medium, equivalent weight N factor is 5. Right? Molecular in the equivalent weight N factor. Sir, KMnO4 N factor in the acidic medium is 5. So it is 158 by 5. It approximately it will give 31.4 or 31.6 approximately it will give. Answer is B. Answer is B. Good. Now the next question. How many electrons are having that quantum number n is equal to 4 and L is equal to 2? How many electrons are having that quantum number having n is equal to 4 and L is equal to 2? L is equal to 4 and n is equal to 2. What is the answer? How many electrons? Good everyone, good. Answer is 10. See, if the n is equal to 4 means possible L values are 0, 1, 2 and 3, and is asking how many electrons are present in L is equal to 2. L is equal to 2 is nothing but 4d. D can accommodate how many electrons? 10 electrons. Answer is 10. Good everyone, good. Everyone good. Next one. The next question I just want to give you. I will write some reactions. Now you have to say me the answers for it. O gas is converting into O minus 2 gas. Right? Second one, N gas is converting into N minus gas. Right? Third one, hydrogen gas is converting into H minus gas. Fourth one, neon gas converting on Ne gas. Next, fifth one, sodium gas converting into Na plus gas plus loss of electron. Now here how many of the following are endothermic how many of the following are endothermic in nature? How many of the following are endothermic in nature? Delta H positive. How many of the following delta H is positive? How many of the following delta H is positive? How many of the following delta H is positive? How many of the following delta H is positive? How many of the following delta H is positive? How many of the following delta H is positive? How many of the following delta H is positive? How many of the following endothermic? Only one. How many of the following are endothermic in nature? What are How many of the following are endothermic in nature? And what are there? How many of the following are endothermic in nature and what are there? How many of the following are endothermic in nature and what are there? My dear friends, whatever the answer you are giving, it is wrong. That is not the correct answer. Whatever the answer you are giving, it is wrong. It is not the correct answer. Once again, you cross check. Once again, you cross check the answer and say me. Once again, you cross check the answer and say me. Should I explain? No. Should I explain? My dear friend, should I explain? Or are you trying? Now the answer is 4. Now the answer is 4. Now the first one is endo, second one is endo, fourth one is endo, fifth one is endo. See here, hydrogen is gaining the electron. Hydrogen is gaining the electron. Now hydrogen is gaining the electron means electron gain enthalpy. Electron gain enthalpy is delta H is negative. Clear? Now either this is the second electron gain enthalpy. Already I explained you. Now this is the first electron gain enthalpy. Oxygen gas converting into O minus. Now O minus gas is converting into O minus 2 means second electron gain enthalpy. Second electron gain enthalpy is always endo at it is delta H is positive. Next, nitrogen due to the off-field stable electronic configuration, nitrogen will not take the electron very easily. So nitrogen, it is having the what? Positive electron gain enthalpy, that is endothermic in nature. Next one, neon. Neon, it is a which one? Neon, it is a noble gas. Noble gas will not take the electron. We have to give the energy. So it is endo. Now sodium it has lost the electrons. Loss of electron is nothing but ionization energy. Ionization energy means we have to give the energy. Giving of energy we call it as endo. So among the 1, 2, 4 and 5 are the endo in nature. I hope it is clear. I hope it is clear. I hope it is clear for everyone. Right, my dear friends, by this I was ending the lecture here. I hope it is clear for everyone. If anyone are having any doubts, they can ask. The remaining they can focus to the other subjects. The others they can leave and focus to the other subjects. Yes, done. Okay, fine. Right. Good, everyone, good. No. Right. Anyone they are having any concern? Anyone they are having any concerns? Or anyone they want to ask anything? Anyone they want to ask anything? Okay, good. Okay, fine. Bye. All the best. All the best for the tomorrow's exam. Everyone, bye. Right. Okay, bye. 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 Right. Okay, Rana, see you tomorrow. Bye. Okay, bye everyone.